Alright, so let's talk about how we can use TIA Portal, right? So this is probably your first time ever trying to use a Siemens PLC in the class, and we need to know how to start a project. Similar to Studio 5000, there's a few steps you have to go through to actually start a new project. If you were to look here, you should see a TIA Portal version. Now, during this recording, it's version 11. It could have been updated between here, but you would still click on TIA Portal to actually do that. So a version update could kind of change maybe a few steps, but for the most part, this should still follow true as long as you are following the steps here. So let's create a new project, okay? So let's name the project first. All right, so we're just going to call it our first project. And then hit create. Seems easy enough. So as this thing is loading, we're going to wait here for it to load. And then boom, there we go. So what I like to do once we get to this point is just click over here to this project view. Do a left click on it. Alright, then once we get here, we can kind of start adding in our device. Alright, so the first thing we'll do once we get over here is we'll add a new device. So like the left double click on that. Alright, so the PLC that we will be using is the S7-300. Okay, the reason I know that is because it's listed right on the front of the PLC. So, if you look on the actual PLC, kind of below where the run and stop button are, you'll see that it's a Simatic S7-300. So down click here, and it's going to ask us what CPU we're using. This number is located on the PLC. So if you look at that same, you'll have the power slot there on the first left thing, and then you'll actually have the PLC as the second kind of item right there. If you look at the very top, it tells you that it's a CPU 314C-2 PNDP. So it's going to be this guy right here. So let's click this down arrow here, and then we can verify that our catalog number is this by looking at the bottom of our same card. Down at the bottom, it's going to give us that 314-6EH040AB0. Alright, and when we click on that, this is kind of what it looks like here. Alright, now with a version, it doesn't let you choose a different version, so we're just going to say OK. Alright, sometimes it takes a few minutes for this stuff to load up. Alright, so now you'll see that we have a rail here. We have our PLC with our IO here, our analog, and our digital input, digital outputs here. Okay. One thing I would tell you to do, you don't necessarily have to do this for it to work, but I would like everybody to go over here to our filter, and below rack you'll see PS for power supply. Let's click on our power supply and add a power supply in here right beside the actual PLC. So if you look to the left of the PLC on your computer there, we're going to be using the PS3075A. Alright, so if I click this down, I'll be using the POS5A. So I'll expand this here, and you have two options. Notice the 0AA0 is the same on both of them. The biggest difference is right here. This one's a 01 and that's a 00. But if again you go down to the bottom of the PLC or the power supply, on the bottom lip of the card where the card door kind of opens, you'll see the number, and we're using the 00. Okay, so you can left click on it and we can drag it right there, and then now we got our power supply. Alright, once you have this in, you're somewhat okay with everything. All right. Now, one thing I will tell you to do is if you click on your card here, which is our inputs and outputs, this first one is going to be a analog card, but this second one here, if we click on it, you'll see inputs and IO addressing. So right here under IO addresses, you need to make sure that you change the start address to a 0, okay, and make sure you change the output start address to a 0. I don't know why, but for some reason by default the Siemens PLC starts it at 136. Don't ask me why, I really don't know, but just change it to 0, because if you start running your project in your project block over here, and it's going to not see your addresses. So make sure you change that to 0. And the way I did that was I just double clicked on this one here, which is our digital input 16, digital output 16, and I changed the IO addressing to 0 and 0. Notice if we click on this one, it's still got some IO addresses. It's having it start at 800. Okay, so we're not going to do anything with that, but just make sure for right now with the digital IO, we're starting at 0 and 0. All right. Now over here under PLC 1, if we do the down arrow, you're going to see a bunch of stuff: device configuration, online and diagnostics. Where we want to be is under program blocks. All right, under program blocks, it's kind of like in Studio 5000. This is where our main routine is. Okay, so if you click on main here, you will see our networks. All right, one thing that's different from Allen Bradley to Siemens is the way that the layout is. Okay, so normally you'd have our controller organizer over here on the left, and over here on the right we just have a big ladder logic page, whereas in this case we just have like a one rung network. Alright, so Siemens likes to, for some reason, put everything in networks. On mine, there usually is some hotkeys right here for your bit logic. I don't know where mine has gone to, but usually above here you'll have all your normally open, or your XIOs, XICs, and if you don't see them, over here under the basic instructions right here tab, you'll see bit logic instructions. There's my XIC, my XIO. Okay, so as far as the XIC and XIO work, you just kind of left click, drag, drop, and then boom, there you go. Notice how when I dropped an XIC down on the network, it automatically drug up another network here. So I'm just going to drag down an XIC and an output. Now right here you could start doing in your tags here, but another way to do your tag is to come in here to PLC Tags, and then under this right here you could go to the show or the default tag table, and then this is where you would actually add in all your tags. Alright, so we're going to do a couple of alias tags as we would do in Studio 5000. So I'm going to name this one S1. Alright, and under data type, right, this is where it's going to be a little bit like what you're used to seeing. It's going to still be a bool, but under addressing here is where it's going to change. Okay, you'll see that it's %I 0.0. Alright, so for an input, you're going to keep this. If you click on this down arrow here, for an input, you're going to keep this as an I. But for your addressing, if you're using the first 0 through 7 bits, you would keep this number as a 0, right? But let's say that I want to use bit number 8, right? You then have to change the address to a 1, and it would look like this. Boom. So now it looks like S1 is 1.0. Okay, so 1.0 actually means that it's just bit number 8. Okay, Now with the light here, we're just going to say P1 for our light, and it's automatically going to drag down an address and say, hey, you're going to use input 1.1, because it's going to assume that you were doing all your inputs before you added your outputs. But to change this to an output, what we're going to do is change this from an I to a Q. All right, and now let's just say we wanted to use, output number 2, right? So we would change this back to a 0, and we change this to a 2. All right, and then now input number 8, output number 2. Okay, go back to our main block here. If we click on this, you'll see our S1 and then our P1. All right, notice how it's got the different things up here. Now you can add in, let's see, I think you can, let me go back to my tag table, comments right here. So if you wanted to add kind of like a name comment, you could just say it's the S1 or green push button on Festo trainer. And then this one you could say is the green light on Festo trainer. Alright, then when you go back here to your main tag, you'll see that it gives you an actual description of what it's doing. So I kinda like that. As far as your run comments go up here, you can do in your comments right here, just say start button turns on a light. Okay, then you got your run comment there. All right. So a lot different probably than what you're used to seeing in Allen Bradley, but the most of it is still somewhat similar to what you would see using like the XIC XIO instructions. All right, now I'm going to talk about timers for a few minutes. So we have our timer on delay and our timer off delay. All right, for a TON, we could come over here and drag this TON to our network, right? And let's just say we want to call this like a start timer. So we name it, we'll keep it automatic, we'll click OK. All right, and it gives it a name up here on the actual above the timer. So if you've worked with timers, the biggest thing you're going to see that is different is the input here is how it's enabled. The Q is the output. So when this Q is done, it sends it'll send a true statement out to an output that could be over here. All right, let's just say that we wanted to run like 3 lights. We wanted a light to come on while the timer is enabled. We wanted a light to come on when the timer was done, and then we wanted a light to come on while the timer was essentially timing. All right, so it's not as easy, in my opinion, to make all this happen when we're talking about maybe the timer timing bit with the TON. And I'm sure there may be other ways to do it, but the only way I've really found out how to actually use the timer timing bit is to actually use like an XIC instruction added with an XIO instruction that will say that the timer is enabled, but yet it's not done. And then that, while one XIC is true and the XIO is also true, then we can have a light come on. So let's go back over to our default tag table, and let's say that we want to add in 3 more lights. So let's just use, we'll call it timer enable light. All right, timer timing light, and then timer done light. All right, so Q02 3 4 5. All right, good to go. In our comments, it'll just be light on while is actually enabled. Light on while timer is actually timing, and then light on while timer is actually done. Okay, now yep, that'll be good right there. Okay, so go back to our main block here, and let's say that we want to have a start button start our process. Our P1 light will kind of be, let's rename this tag to our run light. Okay, run light. Alright, so while if this light is on, this means that our project is actually running. So let's enable our start timer by using our run light. The way we're going to do that is we're going to go back up to our bit logic instructions. I'm going to choose an XIC, and then we'll just drag that information down here. Oh, I thought maybe you could, maybe it doesn't like for you to steal it. So I'm a little bit green with Siemens, but I'm used to doing things in Allen Bradley. Alright, so now our run light will energize our timer on delay. Now, when we press start, the timer will be enabled, okay? And depending on what our preset value or what our time set is, which is our PT here, then when that's reached, our Q will go done. Alright, so right here on PT, let's put this for let's say we want to do 10 seconds. So if we do type this in, we're going to have to do a 10, and then we're going to have to do a capital S for 10 seconds. And now it's going to say that our timer number is 10 seconds. Let's say that we wanted maybe a half a second or something. Then we would just type in, 500 milliseconds. All right, that would be like a half a second. I think that's correct. But 10 seconds is what we're going to actually use. All right. Now with the ET here, I'm not sure what the ET is. Okay, so I'm not going to even try to explain that. But just know that it is actually not needed to do what we need to do with this timer here. So we've got our start button. That goes true. Our run light comes on. Our run light is true. This will enable. And then when our timer is timing, we will turn on a light, and then with Q is when it goes done, Q will actually send out an output there. All right, so right here on this rung, let's have an XIC, an output energize. Oops. All right, let's have on this next rung or network here an XIC, an output energize. And then on our last network here, let's do another XIC and another output energize. All right, so let's get rid of this guy here. All right, right here, we want to have this light. So let's choose our output first. We want this to be our timer enable light, okay? So when our timer is enabled, we want this light to come on. So the instruction we're going to use is from our start timer here. All right, and then we're going to use the IN function, okay? And it's as simple as that. When the start timer is enabled, the timing light will be on. Now, right here, we want to use another start timer function. This time, what we want to do is say if our start timer is enabled, right? And, so we're going to have to do an AND statement. I'm going to grab a XIO. Let me go back now here to the logic. We're going to have to do an AND statement for our timer timing. So we're basically going to say if our start is enabled but our start timer is not done, how do we know it's not done? We're going to use the output, right, which is Q. So if our timer is enabled but not done, turn on the timer timing light. All right, and that's how you can get the timer timing bit. Now, lastly, when our timer is done, we're going to use an XIC here with our output, and then we would do our timer done light. Excuse me. Alright, so timer done light. So we've essentially got 5 little rungs here, 5 different networks. Start button on the light, run light enables start timer. When start timer is enabled, timing light is on. When start timer is enabled, but, or let's just say and, not and start timer is not done, timing light is on. And then lastly, start timer is done, timer done, light is on. Okay, so we got all our run comments. Alright, so you don't have to have your run comments in just to test it, but essentially I know all this is going to work, so I went on and did my run comments. Now what we would do is we would connect. Okay, currently with our outdated version 11 software, this is how I know that everything's going to change. We have to connect by using an MPI adapter. Okay, so when I hit download here, so this is the download key, we're not going to be hooking Ethernet, we're going to be hooking through MPI. Now the PLC is too far away from my computer for me to actually be able to reach it with the MPI connection, but here what you would do is you would type in the PGPC interface, you would choose MPI, and when it saw the MPI adapter here where it says PGPC interface, you would be able to say that you're using a PC adapter, and then it would actually see it and the device would actually show up here. Now again, it's not going to show up here for me because I am at the instructor computer and the PLC is too far away for me to actually be able to reach it using a USB. It's just a USB connection, I do believe. And so that's why it's showing a broken network here. But if this was connected, you would see a solid network here. I'd be able to download to my PLC and get it in the run mode there. So hopefully I can make a video once we get the Ethernet stuff and get all our other stuff hooked up. I can make a video showing you how to download it, but it's pretty simple after that. So hopefully this helps you with our how to actually start a project and how the actual timer on delay works. Okay, now your timer off delay here under bit logic instructions is basically the same way with that it would work in Studio 5000, right? So once you do a timer on delay, you could just say it's just a in timer or whatever, automatic. Same thing, you still have an input, still have an output, still have your time here. This time what you have to do is you have to enable the timer, and then let's say that we wanted the motor to run for like 5 seconds after we killed the timer. So what we could do is we could have a light that's enabled here, and then for instance we want the motor to run for 5 seconds once we disable the timer. That's how a timer off delay works, is you have to enable it. Once it's enabled, you kill the rung by disconnecting whatever input is feeding the timer. Once you do that, the timer starts to time for the amount of time you have set here, in this case, which would be 5 seconds. And once it's actually done, and goes off. So we'll do both of the timer off delay, timer on delay, so you can see when they're actually ready to go, or when the lights come on. But this is basically just trying to show you how to get through and set up your inputs, your outputs, and your actual timer instructions. This little glass right here where it says monitoring on and off, once you download, it's going to be orange. It's not going to be green like in Studio 5000. If you hit the monitor here, then you can actually see like the green on each rung. So like if it was true on this side, you would see a green light up on this rung here to this point. Once this rung went true, you would actually see you would see the line here go green to the run light. Now, just note that for this circuit to actually work, you would have to hold in the start button the whole time because we did not branch around it, okay? But you could branch around it the same way you would branch around it in Studio. So, let's see here. XIC. Go back up there like that. Alright, so you have to branch around it by going here and going back up. And then we could just call this the run light. And we'd have that. Now we'd have to stop it, put a stop button in here. But we could put that right here. We could call it stop. See, I don't think it lets you I don't know if it lets you define it here. Yeah, there you go, define tag. So this is going to be a Boolean where's this at? I'm not sure how to do this from right here. I would just delete it, go back to your default tag table, make it stop, and let's change it to an input here. Change it to an I, and we're going to call this number 0, and let's just call it stop button, and then go back to our main. Find stop there, and there you go. So now if you hit start and stops closed, run line will come on, stay on until you hit stop. All right, timer works the same way. Once the rung dies, this gets reset, so you don't need a reset for it. It's not a retentive timer. I'm sure they have a retentive timer in here. I'm not sure which one it would be. Now you'll notice, I guess this is like maybe function block or something like this, the different languages there, not sure. But anyway, that's a brief overview of Siemens. We'll see you next time.